Okay, this is a quick video run through of some code I wrote recently called pyniviz. It's designed to emulate a quite popular plotting software called niviz, which is generally used to plot the .pro style output of the snowpack model. You can find some information about the module on GitHub here, as well as some basic documentation about how to use it. But there's more comprehensive documentation on the ReadTheDocs site, and that's going to stay probably much more up to date because it's automatically generated. So you can look at all the different functions and things like that in here and how they work, especially if you want to contribute or if something's broken. As you can see here, the best way to download pyniviz is through the Python package repository, pip. So to download it, you can just do pip install pyniviz. Cool, you can see there that by doing that, I've downloaded pyniviz 1.0.10. So now I'm just going to give you a quick run through with the Jupyter Notebook of how it works, in essence. So I'm going to clear everything. Most of the functionality comes through the main module of the pyniviz package. So to start, we're going to import main. Don't actually need to do that. And I'll just show you the most basic functionality first, which is just finding a file, sample.pro. There's no preamble to that file name because it's in the same directory as the Jupyter Notebook. Sample.pro comes in the GitHub repository, so you can just download it from there. And to plot sample.pro, we need to choose a variable to plot. So in this case, I've chosen element temperature. So run this code, the most basic plot appears. There are obviously, if you're seriously analyzing model output, you might not just want to look at the whole plot at once. You might want to look in a particular height range. Just so you know, this is actually the sea ice variant of snowpack, so it looks a bit like there's a snowpack floating in the air, but it turns out that in fact, if you look at the GitHub page, this corresponds to this sort of thing where there's an underlying ice layer that's floating on the sea. So we might want to look at the height of 400, which roughly corresponds to the ice surface, up to 420, which is safely above the top of the snowpack. So to do that, we can use the ymin, ymax arguments, and that crops us into just part of the snowpack. And the same functionality exists along the time axis. We can define a start and an end date or time. We do that with the Python datetime module that's built in, and we pass xmin and xmax to the plotting code. So this is going to crop in on the information that comes after the 29th of January and before the 8th of February. If you want to save the plot, you can just pass the file name keyword. We'll save this as file tempfig demo, and that will save quite a large publication quality plot. I might put some functionality in to perhaps decrease the size of the plot, although my approach was you can always make it smaller and lower res if you want to use it now. So we'll just look at tempfig demo. There it is. You might notice that the y-axis starts from 400 centimeters. That's obviously not ideal, you might say. So to fix that, we can actually subtract a fixed number from the y-axis. And we can also change the color scheme. So here we're going to shift it from plasma, which is the default, to reds. So that's how to plot a continuous variable. You might also want to plot a non-continuous variable. So how do you actually get the names of these variables? Because if I'd gotten this slightly wrong, and maybe thought it was in the PRO file as capital E, then the module wouldn't know what to do, but it does give you a list of the full variable names. And it also gives you a list of some pyniviz recognized shortenings. So instead of writing element temperature brackets degrees C, I could have actually just written temperature. So to get those shortenings, rather than just doing it wrong deliberately, you can import tools from pyniviz and get the shortenings straight away. There you go. So if we want to look at the grain type, we could use the long variable name, and that's what's in the PRO file, or we could just use the recognized shortening, which is grain type. So that's what that looks like. You might notice that the color scheme reds is just ignored because the different grain types are shown on their own special color scheme. But that's basically it for plotting grain type. But if you have any other suggestions, then just let me know, or you can put in a pull request on the GitHub, particularly if you want to change the color scheme. I tried to mock up the official pyniviz color scheme, but there are some differences that I thought would basically just look a bit better. So there's some more advanced functionality that goes a bit to the heart of how this code works. A .pro file is quite confusing. So there's lots of lines. Each line corresponds to a variable, and it gets repeated periodically, and that period corresponds to the time step of the model. So what pyniviz does is it imports a data frame, a pandas data frame, for every time step of the model output. So essentially, we can, under the hood, it's importing a list of data frames. So let's just quickly investigate that functionality. You can get at that list of data frames through the readPro method. Up here we use the plotPro method. So we can just look at this list. It would be quite long and horrible. It doesn't want to show me. Okay. So let's look at the first element of this list. And just the columns of that data frame. So these are the columns of the data frame that's imported. That's the head, the top of the data frame. The top of the data frame slightly confusingly corresponds to the lower part of the snowpack, but it's got height axis, so there's hopefully no confusion there. So how do we actually select the data frame that we're interested in, the one that corresponds to the point in time that we'd maybe like to investigate or plot? At the moment, you've just got to iterate through and get the timestamp for each data frame, which is encoded in a special column of the data frame called date. Oh, this is more complicated than it needs to be, actually. So here we just iterate. Oh no. So here we're just iterating through the list of snapshots. I call the data frame snapshots because they represent the snowpack at an exact point in time. And we get the date from each snapshot with this line. And if the date corresponds to our time of interest that we specified up here, we bind that data frame to the variable data frame to plot here. So we've got this thing called data frame to plot. That's what we're interested in. That represents the snowpack at a certain point in time. And here's some plotting code that basically just plots that. So we're plotting here the temperature against the height of the snowpack. So I'm going to put height on the y-axis because it's perhaps more intuitive. And we're also interested in the grain size. So there you go. That's how you plot variables from a .pro output of snowpack with pyniviz. I hope that's helpful, and if you fancy using this or improving it, then just put in a pull request on GitHub, and I'd really gladly take any input.